that did the Earth from Space Challenge. So the rest of my team were actually all here. I have Patrick, Scott, Hannah, and on keyboard today is Dan. He's going to be controlling things as I talk. Hopefully everyone can see. So as I said, we did the Earth from Space Challenge. So that challenge was to take a program called the ISS CAM, CAM being K-A-M, standing for Earth Knowledge Acquired by Middle School Students. And the idea here is that they could actually choose locations all around the Earth for the camera on the ISS to image. So they actually got to choose location. The ISS, during one of its missions, would actually take pictures of that. And there's a website that's currently up and run by NASA that you can browse all these images. We counted there's almost 13,000 images up there, I believe. So there's a lot of images. And the idea was, how can we make this more accessible? How can we make it cooler? How can we do things? So a few of us, as you heard, work on an open source project called Cesium. And the interesting thing about Cesium is that it is a WebGL-based 3D globe and a 2D map. And Dan will run around and show you some of the features here. So we have 3D globe, Dan show them 2D. And the important difference here, one of the technological newness things of this is this all runs within a web browser without an install. There's no downloads, no plugin, no setup. Almost every web browser is supported. Almost every device is supported. So even tablets would be able to run this. And it makes it a lot more accessible. So no one has to download a Google Earth or plugin or anything. You just go to the website, you're there. It can even, we're doing full screen, but it can even embed it in the page. So you could have other data on the page and then just a window like a movie, but instead have a globe there. And did you go to 2D? Okay. So that's the general purpose. And one of the things we do, we're called Cesium because Cesium is an element inside atomic clocks. We're actually very time aware. So there's a little time bar down here. Dan can speed things up and slow things down and kind of scrub around. Great. Now, the next step is to actually look at the EarthKAM imagery. So NASA supplied us with a set of CSV files, and we were able to read those in, and have a list of different missions. Each mission is a different CSV file, and what you see is all these little polygons, Dan, zoom in a little, on the Earth are actually where images were taken. So you see the images taken, and then the ISS is actually the ephemeris of the ISS at that time. Okay, so we're propagating the two-line element set for the ISS at that time. Now, you can follow the ISS, as Dan said here, as it's taking pictures, or hit the home button first and then click on a polygon. When you click on a polygon, it'll actually fly to that polygon, and it'll load the image off of the website. So now you can actually see the image, for the most part, geolocated where it was. We actually found some of the images didn't quite line up, but that's something we'll look into. And what you also get down here in the corner is the metadata that's also existing on that image on the website. And you can actually click on that, and it'll bring you to the website for that image. And finally, we started some early social interaction. And well, I'll point out here, as you can see, when you clicked on the image, it put the ISS at that time. So you actually get a sense of the track. So even though these images, all look close together, they were taken very far apart because they were taken on these different runs as the ISS did a pass overhead. And finally, we started our social media integration. So for now, we just have a tweet button. Eventually, we hope to actually have inline comments for other social media websites so people can annotate an image or share or discuss the image more. Finally, Dan actually was our cutting edge guy, and he did some leap motion controls. So hopefully it'll work here. And so now also let you kind of control the camera, zoom in and out. And we're close to having picking working, so you can actually get to a polygon and select it all with the camera. So yeah, I asked for a karate chop motion for something, but I don't think we can do that. So, and then finally, where we're going with this, regardless of the outcome of the NASA Apps Challenge, since we work on this open source project on the side, Cesium, and this project's also open source, we have a GitHub repo already set up for it under the Apache license, so if anyone's interested, feel free to come contribute. And we plan on continuing this, and with or without help, to just have a demo to kind of show this in exploration. We also know there's a MoonCam project, so this should be able to easily be adapted not only to the moon data, because we can do more than just the Earth here, but also to any kind of geovisualization project and data that NASA might have. Yeah.
Seconds if the judges have any questions, but sure. Team Cesium.
And they're all here. We had some external interest, but they never replied.
Tell me about Cesium. You're running this on local host, but what do you do that? You do something in the background?
No, it's actually deployed on a web website. What's the address, Scott?
cesiumspaceapp.cloudapp.net.
Yeah, there's a link. If you go to our project README, there is a button there that will launch the public version.
Space app.
So you tell me about the 5 seconds when it installs.
It's all HTML and JavaScript. There's zero. The only thing that we had to run client side here is I had to install the Leap motion drivers for my system, but outside of Leap, it is all. That's the idea. So in theory, you go to this on a Nexus 7 or something, and it'll just pop up and be interactive. You know, we haven't tried it yet, so. But it will. In a month, it will. It just depends. All right. Big round of applause. Thank you very much.
Next teams.